Hi, I'm Nate Blair, and I'm one of the software developers and product managers here at NREL that works on tools and data for the solar industry. And we're here today to talk to you about and expose people to a number of different tools and data sets that we have here at NREL and make available in this short little video so that you can hopefully use them in your projects. We'll just take a second to get the video up. Okay, and what we have here is a series of slides, and we will just step through them. I've already introduced this, so I'll get going right away. First of all, here at NREL, we provide both websites, maps, documents, data sets in a variety of different formats, and I'll start with what we almost consider old school at this point, which are maps. We have a lot of maps available at NREL. We have a robust GIS team. And these are available in a searchable format at our map search website. Next, let's move on. One of our big data sharing tools is called the Solar Prospector, and it comes off of our maps.nrel.gov. You've heard of maps.google.com. Well, maps.nrel.gov is our site for all of our geospatial applications, so it's a great place to start. The Solar Prospector provides a variety of different information, but really focuses on providing time-based solar radiation data throughout the United States at a very small grid cell, and we tie to it from some of our other tools like SAM, and it's built with this kind of underlying framework. So Solar Prospector is a great place to go when you're looking for siting issues, looking for data sets that are available geospatially related to solar. OpenPV is another one of our geospatial projects. The goal of OpenPV is really to provide information about every single PV system in the country. And we do this by talking with subsidy providers, states, installers. Installers can upload their own systems if they want to. And so we try to create a database through time that's specific to a certain location. As you can see here on the graph, you can look at the whole country. You can also zoom into specific states and down to the county level. And this is particularly important in areas that are very active in solar installations. Open energy information. Just like OpenCarta was our platform for GIS applications, Open Energy Information is a platform for open data. And so this is another great place to start if you're trying to find different data sets or what's available throughout, in some cases throughout the globe in terms of solar data and solar information. On the OpenEI or Open Energy Information platform, we also support a couple of different tools which could be of interest. The first I'll talk about is a transparent cost database. So this looks at thousands of reports and pulls the cost data out of them and puts it into this nice, easy to use framework so that you can compare and contrast different types of costs for different technologies in the and then you can drill down into the particular data piece and the cost point that comes from a document. So that helps you also dig through to find out what cost documents are available. Another tool and database that we have sitting on the OpenEI platform is called the Utility Rate Database, which has tens of thousands of rate sheets entered in a quantitative way from over 3,000 utilities. And we use this ourselves to enable complex rate analysis. Some of you know time of use rates, tiered rates, etc. Really impact the value of a PV system, particularly for a residential or commercial building. So you really need the complex rates that are being used, particularly in robust solar markets like California, to accurately calculate the value of a solar system. We also use the API that sits behind this in several other tools, including SAM. And we've been working for the last 3 years with Illinois State University to really populate this database and get it really robust, covering all of the utilities in the country and with very recent data. PV Watts. PV Watts has been around since 1999. We have a variety of organizations that use it and subsidy providers that use it. It's a simple online tool for non-experts needing basic solar performance estimation. You only need about 5 inputs about your system in order to get results. We use that really robustly. The other thing I would say about PV Watts is that just yesterday, on September 8th, we released a new version of PV Watts that updates both the look and feel as well as the results. So please go check it out at pvwatts.nrel.gov. Crest is a spreadsheet tool that really looks at the financing of solar systems. And it has other technologies as well, but it started as a solar-only tool originally and has branched out, and it really helps you try to figure out what the impact of various subsidies and incentives would be, and it's based on a spreadsheet, and a lot of analysts are very comfortable with that. And it really should enable policymakers to assess projects, design incentives, and evaluate the impact of tax incentives or other support structures on the cost effectiveness of solar. And finally, our most complex performance and finance tool is called SAM, or the System Advisor Model. It is unique in that it combines a detailed performance calculation similar to, say, PVSys or PV, if you're familiar with those, hourly over a year, and then combines that with a cash flow model that really looks at a variety of financial impacts. To get to, in the lower right corner here, you see some of our metrics. To get to the levelized cost of energy, the net present value of a system, the payback, revenue, capacity factor, and so forth. Related to the SAM tool, we also have a kit for SAM, so you can run the entire engine for SAM through scripts. And we have a number of corporate partners that are using the SDK. It's free to download at the SAM website at sam.nrel.gov. We have built several hundred pages of technical documentation, and in addition, we've built wrappers to easily call SAM functions from C#, MATLAB, Python, and Java. And we're working on some more. And we have a little bit of a user interface to actually help build applications for the API and deal with the scripting that's needed. Kind of stepping away from the performance calculations and more into the economic development and economic impact area, our JEDI tool is a robust tool that really looks at how many jobs and the level of economic impact that would be associated with a large solar project. And the JEDI model stands for Jobs and Economic Development Impact, and sits on top of a database of economic impact data, and then allows you to say, hey, we're going to build, say, a 50 megawatt PV plant in this particular location. How many jobs will be created during construction, after, the induced impacts on the area, and so you can really get a objective, robust, analytically based estimate of the economic impact of a new plant. One of the last things I want to talk about today is web services. So NREL provides a number of web services for use by the community. What we really want to do is not have to build all of the websites ourselves, but encourage people to use our data sets, to use our algorithms, so that they can really focus on the particular part of their website that's unique and is an added value. We use a number of these services ourselves. For example, in our PV Watts tool, Energy.gov hosts state and local economic or electricity data website, also known as SLED. That uses a number of these APIs, and we use them internally for some of our own tools. So we're using these web services as well as making them public and free for other people to use. So you can see we have a number of them here. PV DAC is a tool that we didn't talk about too much, but it provides PV performance data collected at NREL for systems throughout the country. This is the API to access that. There's also a web interface for PV DAC. Desire incentives, we've worked with the Desire team for a number of years to create quantitative data out of the incentives information that they collect, and we've been using this. We use this within the new PV Watts tool. Utility rate data, we have sort of two types of utility rate data. We have complex utility rate data from the URDB, and you need to then build calculations on top of that to use that data. But in addition, we provide average utility rate values. So say my utility, the average price in 2011 was 11 cents per kilowatt hour. So that's the type of data for a residential customer. So that provides that for residential, commercial, and industrial sectors, and based on a location or a lat long that you provide to that web service. PV Watts, the current one as of today, is version 5. This is publicly available. It changes the results and the D-rate defaults. We are leaving available PV Watts version 4, which was the one that up until yesterday was the current version for PV Watts simulations. We have a number of companies, both large and small, that are using the PV Watts version 4, and we assume they will over time migrate to version 5 of the web service. And lastly, solar resource data, similar to what you can get by clicking through the solar prospector. We provide various types of solar data for a location, including the average DNI, average GHI, and average power output for tilt equals latitude. So those are high-level calculations that can be done that may be useful for a particular application. So lastly, we've included a number of different links here. I would recommend making sure you check out the maps.nrel.gov link, the openei.org link. There's a lot of information at OpenEI, as well as a couple of the tools that I mentioned. And lastly, if you're a developer, please check out the documentation of our web services at developer.nrel.gov. So that's all I have for right now. Thank you very much.